Hello, I am Muhammad Asif. Hope you are enjoying happy and good life. Our today's topic is fractional distillation. Fractional distillation. Now, in the previous video, we have discussed a simple distillation. And I have explained that simple distillation is the separation or collection of liquid from a solution of liquid and solid or salts. In simple distillation, it was quite clear that only the liquid component will boil and the solid salts will never boil. That's why on heating, liquid will change into vapors, and by using condenser, those vapors will be condensed back into the liquid, and we easily get liquid component in a pure form. But in case of fractional distillation, this distillation is used for the separation of miscible liquid components. Miscible liquid components, those liquid components which are mixed with one another. For example, we know if we put oil into water, both of these will never mix because oil is organic and water is inorganic. According to the like dissolved like, both of these components, oil and water, will never mix. And if the components are not miscible, then we use technique of separating funnel, which we have already discussed. But if the liquid components are miscible with one another, miscible liquids, fractional distillation technique is the separation techniques of miscible liquid components which have different boiling points. This technique is basically depends upon the difference of boiling point. Difference of boiling points of liquid components. Now, this technique is used. This is the basic principle of fractional distillation. That this operates on the basis of the difference of boiling points of the liquid components which are present in the mixture, and those components are miscible with one another. Those are thoroughly mixed with one another. For example, if I have a water in a beaker and if I put ethanol into it, H25 C2H5OH, ethanol into it. Now, ethanol and water will be miscible with one another. This will become a mixture of ethanol and water. Now, we know that the boiling point of water is 100 degrees centigrade, while boiling point of ethanol is 78 degrees centigrade. Now, as the boiling point of both the components are different, using fractional distillation, we can easily separate both of these components. The apparatus used is here. This apparatus is used in laboratory for a small scale separation. In the school or college laboratory, we have such type of apparatus available, and we arrange whole of this apparatus in such a manner that this is a round bottom flask which contains a miscible liquids mixture, miscible, which are 100% thoroughly mixed with one another. Now, this is the fractionating column. Fractionating column. What does mean by fraction? Fraction means part. If we have a mixture, then all the components of a mixture are called as fraction. As I have given the example of this water and ethanol mixture, then ethanol is one component and water is second component. Ethanol is one fraction and water is second fraction. So this is called as a fractionating column. This is the thermometer. The adjustment of thermometer should be such that the bulb of the thermometer must be in level with that passage from where the vapor has to go out into the condenser. The thermometer bulb should be in level with that passage from where the vapors go out into the condenser. Now, this is a condenser. This condenser condenses the vapors, and in this condensers we cold water enter from the bottom, and the hot water, after absorbing the heat energy of the vapors, goes out from the top. Now, movement of the water and vapors should be counter current, should be in opposite direction. That should not be in the same direction, otherwise there will be a problem in condensing process. Now, this is our delivery tube, this is our receiver flask, and the vapors which condense into the liquid, those are collected in this receiver flask, and this is called as distillate. Now, this receiver flask should be opened so as when liquid enter into the flask, then the air trapped in the flask should go out. If it doesn't happen, if it is airtight with this delivery tube, then the collection of the liquid into this receiver flask will not be possible. This will be the big mistake. We have to give the passage for the escape of air which is present into the flask for the proper collection of the vapors in liquid form. Now, the most important is what is the function of this fractionating column and which material this fractionating column contains. In the normal fractionating column, as I have mentioned here, a small beads or small pieces of glass or small pieces of ceramic material, broken pieces, can also be used in this fractionating column. Likewise, for the more accuracy, this fractionating column is filled with alumina. Alumina is a non-reactive material, beads, small beads. Alumina mean the beads made by Al2O3. These can also be used. What is the function of the fractionating column? This is the most important. When we will provide heat energy from the heat source, automatically this miscible liquid mixture will start heating, and the component which will have less boiling point will boil first, and the vapors of low boiling liquid will start coming out at the first stage. For example, if we have taken the mixture of this water and ethanol, then definitely the boiling point of ethanol is 78 lesser than the boiling point of water, which is 100. Whenever we will start heating, the ethanol will change into vapors very fastly, and the water is just gaining heat energy. Now, what will happen? With the passage of time, if the vapors are of alcohol, but side by side due to the rising temperature, the water vapors will also comes in with these alcohol vapors. Also comes, no doubt. These water will be less, but will be there. That will contaminate the vapors of the alcohol. Now, both the vapors will enter into this fractionating column. Now, what will happen? Whenever these vapors will strike with the surface of the beads which are present in the fractionating column, the component with a high boiling point will condense on the surface of the beads, and the vapors of the low boiling component will remain in vapor form and travel continuously up into the fractionating column. For example, if I have represented just like red is the water vapors, now water vapor will condense at this stage. And the alcohol vapors will carry on going upward and will travel whole of this fractionating column slowly and slowly and slowly and reach here. Whenever they will reach to the bulb of thermometer will show the reading 78 degrees centigrade. This will indicate that the component having boiling point 78 degrees centigrade has been reached at the top very close to the thermometer. Now, thermometer is indicating the boiling point of the first fraction which comes to it. Now, vapors of alcohol will start entering into the condenser, and as the cold water is flowing through the condenser will condense all these vapors into the liquid state, and we will get here a liquid component at a particular temperature. Now, remember, as long as the temperature remains 78 degrees centigrade, this will indicate that the same component vapors are coming. Whenever we observe that the temperature is now going to rise more, it means that the component of boiling point 78 degrees centigrade has been totally removed, and now the next component with a high boiling point will start to rise and come at the top of this thermometer. Whenever the temperature will start rising here, we will remove this receiver flask and place it with a new receiver flask to collect the second component of the miscible liquid mixture. This is the method how the fractionating column operates and how the fractional distillation is done for the miscible liquid mixtures for the separation. One by one, all the components can be separated quite easily, and the collection of the condensed vapor can be collected accordingly. This apparatus is normal college or school laboratory apparatus, which works on a small level. On the large scale, on the industrial scale, this is also a fractionating column. This column indicates that it is a large diameter, having a large diameter vessel in which these are the metallic plates, and these metallic plates contain so many different bubble caps, and those bubble caps are designed in such a manner that the component comes here. Now preheated chamber is attached First of all, the mixture is heated, and that heated mixture, miscible liquid component mixture, is entered into this fractionating column. Now, how the bubble caps will work? These vapor will rise and strike with these bubble caps. If the boiling point of the component is high, definitely it will condense quite easily. Whenever it will condense easily, for example, I am going to explain here. Say, this is the shape of bubble cap. Now, whenever vapors will come from this side, vapors are coming. Now, if vapors are striking at the lower side of the plate, they are providing heat energy and heating the liquid. Now, if the vapors are striking this top level, if the boiling point of component is high, it will condense, and on condensing it will change into the liquid. Here, it will change into the liquid. But those fractions which have low boiling point, they will escape from here easily and will move to the next plate, to the next plate, to the next plate. And if the boiling point is very low, that component vapors will never condense on these plates, and all those vapors will move at the top and ultimately will escape out in the form of as a refinery gases. Now, if we take the particular example of petroleum, say the crude oil preheated quantity of crude oil is entered into this fractionating column. Vapor will start rising up due to high temperature. High boiling liquid will condense at the very lowest plate. Low boiling fractions will move to the next plate. Then further low boiling component will move to the next plate. Low boiling will moving up and up and up, and finally the low boiling will, if it is present in the gaseous state, will comes out in the form of refined gases. It means that this fractionated column is going to separate all the components according to their boiling point, and from all these plates, the components of particular boiling point component can be taken out. This is the method. We can collect all these. From each plate, we can get the fractions with different boiling points, and all fractions will be separated on the basis of their difference in boiling points. Low boiling fraction will boil and will move to the top. Low boiling fraction will at the top, and high boiling fraction will remain at the bottom and will comes out as a residue as a result of this fractionating column residue material. Now, this is the method, this is the basis for the fractional distillation, on which fractional distillation operate and how this bubble caps works. Now, three type of liquid mixture we can separate quite easily. Number one, fermented liquor. Number one, fermented liquor can be distilled by using either school laboratory apparatus or by industrial apparatus in any distillery plant. What is the fermented liquor? That liquid in which fermentation has been taken place and the glucose present in it is already converted by yeast into an alcohol. Now, by using this fractional distillation, we get alcohol out of the fermented liquor, and easily we can distill out the alcohol from fermented liquor using this technique. Second is liquid air. Liquid air. Whenever we want to get nitrogen for the production of ammonia, especially in Haber process, first of all, we take air and liquefy air by removing first water vapors and carbon dioxide. Then only two components, nitrogen and oxygen, left. Both of these components are liquefied first, and then this liquid air is transferred into the fractionating column, and depending upon their difference in boiling points, both the components of nitrogen and oxygen are separated. Nitrogen is used for the production of ammonia in Haber process, and oxygen is used as a source of oxygen in oxyacetylene flame or in the hospital for the better respiration, Now, third we have already discussed. Petroleum. Petroleum itself is a mixture of different hydrocarbon components which have different boiling points, but they are miscible. All of these, using this industrial apparatus, fractionating column, we can perform fractional distillation quite easily, and we can separate all the components which have difference in their boiling points. Now, as the number of plates in this fractionating column will be increased, then the accuracy will also be increased, and the components which have a very close boiling point, have 1 or 2 degree differences, that can also be quite easily separated, and pure components we can obtain using this. Now, this is the method. This is fractional distillation. To reduce the cost and to reduce the time, this fractional distillation can also be converted into a vacuum distillation. Whenever we will create vacuum in this fractionating apparatus, definitely the boiling point of the components will also be reduced, and the difference of boiling point will remain the same as such, and using less energy, consuming less time, we can separate all the components if we are using vacuum distillation. This is the modern technique which have so many socio-economic effects, which reduce the cost of production also. Dear students, I have explained fractional distillation with respect to small scale and large scale. I have discussed the function of the fractionating column, and I have explained the difference between simple distillation and fractional distillation. I think you have understood all of these concepts. If you have any query, you can ask, and then don't forget to like and subscribe my YouTube channel. Thank you.